Okay, so yesterday it was the Maxcom 21E, which we ended up having to put the on-the-air test up in two sections after the main on-the-air test ended up with no sound after the 5 mile point. Thank you to YouTube for whatever they've done. So instead of starting again, we've put a part 2. So we've got a Rotel 240 and I don't know what the origin of this is, so rather than test it first, we ought to just open it up and make sure it's safe. I've just popped one of our power leads on that. So what am I looking for? Cracked cores. Can't see any of those. Looking for illegal shenanigans. I can't see any of that. Yeah, it looks alright. This might be one of those sets we do in 20 minutes. The customer sent me a freebie of a Harvard WT44 handheld with a broken aerial. There may be enough aerial for us to do a test with that. I'll certainly do the service job. But we'll have to make sure we've got a full aerial on it, because it'd be nice to do a field test on one of those. But like all the Harvard handhelds, they're best described, although they work alright, they're best described as, there's a good word for this, fragile. Alright, we'll get the test equipment plugged into, we'll get the test equipment plugged into extension speaker, and that's loose. Deal with that. The insulator's missing. That could be detrimental. I'm sure we can recover one off a scrap set. Right, power supply on. It's a bit stiff, that. They have an animal grease to keep them tight, and when they're not being used for a long time it can be over stiff, so I might just pop something. Or has it been dropped on it? We're in danger if we try and straighten it out of breaking it. I think it's been dropped on that. In fact, they all look bent. They are. You can see we've kind of got those three like it's been dropped and it's fallen on its knobs like that. Or perhaps I just hit it with a hammer because I don't want a CB anymore before they threw it in a skip. So Cybernet mic, yes, Cybernet mic. So channel 9 off, 20 select, that to 0, CB normal, we'll have that in high, see if PA works. Testing 1 2, should be on mic gain, 1 2 1 2, right, that works. Good. Well, meter lamp, PA. It's a good start. That's 2 ticks off. Make sure RF gains to full, mic gain to full. Yeah, that is causing a problem. I think it's that. It's shorting out the amplifier. So I'm just going to take that away from the chassis and not lose its other insulator. See whether that fixes the problem. So that's cured that for now. I'll have to find an insulator. Bit of a dirty volume control, but we're gonna have to have the front off this. Well, I may as well start with doing the VCO. Put that on for the earth. Select channel 40. Resistor 4. See, this has been checked. I already can't remember what I'm doing. I'm going to have to get the service manual print out. It must be all of 3 weeks since I did one of these. Right, I normally use the improved one that Mike did, but I switched my computer on and it says, what hard drive? So I thought, oh, just get on with the radio. Cheers, channel 40. I remembered that bit right. It's 4 volts. I couldn't remember whether it was 3 or whether it was 4. Right, here goes. So we do receive first. It's supposed to be 4 volts. It's not. Where's the trimming tool gone? Right, so 4 volts on receive. We're going to transmit. 2.7. So that's near enough. Go back to receive. It's still correct. We'll go to channel 1. And we've got 2.24 on receive. And what do they say? Needs to be between 1.8 and 2.5, so that's fine. And on it's 1.9 and 2.5. And it's 1.8 and 2.5 for transmit. Absolutely spot on. So failure to do that, you can end up with channels dropping out at the top and bottom of the range, and you can also end up with the channels dropping out if the temperature changes dramatically, which you're going to get in a car. Right, so now we'll get on to transmit. So it's now 4 volts plus 4 volts, and what was it? Something like, was it 3.2 and 3.2, something like that. So before we go into any alignment, we'll just see what the radio is actually transmitting on. It's 4.1 watts. Oh, I'm on channel 1. Just change that to there. Channel 40 is 3.6 watts, and channel 20 is bang on the 4 watts. Low power, is it front on this? Yeah. Have a look. Is 600 milliwatts. Back to normal. And the current consumption is 1.21. Deviation at the moment, wallow. It's reading 1.8 on here, but it may be lying. And our frequency test gear has been on a couple of hours, so it's going to be absolutely where it should be. It's 2779102, so it's not really off, but we'll pull it up. 2779102, and I may as well do that right now, and then we won't have to compromise on receive. There we go. We'll come back to receive when I've done transmit. I'm trying to get out to tune an organ as well. It's only a 1 manual, so it should only take about 90 minutes. Right, into transmit we go. Let's go back to the main meter. Oh, we're not on picture in picture, are we? That was silly. That's better. Okay. So, it's spot on the 4 watts. But we need to, it's obviously not right. Centre of the, that was absolutely correct. That was 2. That wasn't. Turn the volume down. Right, get a trimming tool out. It's the blue one for these. Right, so this is the one. This is the clever bit. We want this to, for maximum. We need to get this radio really more than 4.4 watts to achieve a balance, and not all of them will do it. And you know what? This is one that isn't going to. It's doing 4 watts. Right. So what we're going to do in this instance is I'm going to have to turn this clockwise till we just get a movement. So that's 3.95. Then this one anti-clockwise, so we just get a movement. It's 3.95 still. So let's see where we are on channel 1. 3.95, and channel 40 3.95. So it's supposed to do more than 4.4 watts so you can balance it properly, but I've still managed to balance it. So 3.95, 3.95 and 3.95. So we're now drawing current to 1.206. You can see that's come down, even though the power hasn't really, because it's now tuned properly. This is the old meet or exceed specification. This radio is supposed to do 3.8 watts, and we're getting 3.95, so it's in spec. But usually we'll do a full 4 watt. Right, so I should have done this first because we're now not going to get that reading. The meter's banging across, so that won't have changed. I'll put FSD for full scale deflection, and we'll just adjust. We will just adjust the meter preset for 4. Which is there. Low power. Just waggle that around a bit because it can get dirty. I think that one's cleaning. Try once again. No, it's not going to go. We're going to have to change the preset. Right, we'll ignore that for now. We'll do half the deviation, want that to the central position. I'll tell you what, we'll get it out of the way right now. I'll plug into the test set behind me. We'll just make sure that it's correct. Right, I'll have to come back to that because the test set wasn't switched on. Wallow, wallow. It's actually spot on. So we'll see if the Marconi says it's spot on, because it certainly didn't earlier. Wallow. It says it's a little tiny bit low. 2.2. Well, it isn't. Check low power again. That still wants doing. I'll just give it another check. See if we can get it without changing the part. No. Still needs doing. Right, we'll move over to receive. Put the camera on the detector. I'll just make sure we're on frequency. Check the RF gains at full. And let's get some. No, we won't put it on there. We'll put it on there. Actually, it's very good. 0.31. .27. Let's hope the detector's not out and it gets worse. 0.95. Squelch. Put the squelch to full. Let's go over to the attenuator so you can see what I'm doing. 100 microvolts I want it to open at. So 1, 3, 10, 30, 100, 300, 1 millivolt, never opens. Right, threshold. Park the signal generator at 0.3. Set threshold on the radio. About 1 microvolt at the moment. I put 1.1, so that's not right. Right, let's get on with the tune-up. So we'll go to the oscilloscope, put 100 microvolts on the signal generator. Oh, we haven't read what these S meters reading yet. So see if we can actually see it at all. That's S9 and it is 48 microvolts. It's a bit generous at the moment. Okay, detector. Little bit there. Right, now we'll get on with the tune-up. Go to the SINAD meter. Definitely there somewhere. Okay, move that way then. So I want about 3 dB on the SINAD meter. Go down another scale. Start with that one. Gained a bit there. Back off the signal generator. That was absolutely spot on. That was absolutely spot on. That was spot on. Let's put a bit more signal on for this. I think that was as it should be, in the one hidden under this wiring. Yeah, that's already spot on. We've made a bit of a change there. See if it's worse or better. Oh yeah, 0.24. Wow, that's made a difference. For 10 dB, 0.2, and for 20, 0.65. That's as good as the Binatone 5-star. I don't usually find the Rotels perform as well as the Binatone 5-stars, or the Harvard 420Ms, or the SMC Oscar ones. But there you go. This one does. Squelch. Now, full squelch on the radio. Take this back to the attenuator so you can see what I'm doing. And it should be 100 microvolts. So it still never ever opens. So it now opens at 100 microvolts. So that's what we want. So that means this full squelch is S9. And then we'll back the squelch off, turn the signal generator to standby, park it at 0.3 of a microvolt, set the threshold on the radio, try that one again. 0.85. So that's great now. So now we want the S meter to read S9 for 100 microvolts. See what it reads. So it's being generous, so back that off. Dirty preset. Makes me wonder whether it's been a smoker's house, this. There we have S9. So as far as the radio goes, that's now tuned. But we've got some things to do, haven't we? Turn the power supply off. We need to take the front off. I've got something else to do, so we'll come back to this in a couple of hours. If I can pull any of the knobs off, that is. We need an insulator for that. That's 1, 2, that's 5, but not 3 and 4. That's 4. It'd be a pain if I couldn't get this one off, and I've got to go to the organ workshop and get some string underneath it. I see if I can get both hands to it. I have. Remember, I've got exceptionally strong fingers as a church organist. Now we've got to do the channel one. Some sets like the Fidelity 2000, it's actually got a grub screw. So before huffing and puffing at it, you've got to be aware of that. Okay, so been to the organ workshop and back, put it in a vise. So are these bent? Or are they just stupidly tight? So let's have a look whether they're going round squarely. Well, that one is. And that one is. That's stupidly tight. No, they're not. Don't look bent once I've taken the front off. So what we'll do is to apply some WD-40 into the shaft. Let that soak in. I'll take that to Mr. Chippy's workshop, and I'll come back in an hour. Right, well, that worked. So 45 minutes later, having applied WD-40 to the shaft here, I did them all while I was here just in case. They're all perfect. I've also straightened them up. So, put that back on. And also behind the scenes, I've changed the preset. You can see that's now a shiny one. So we'll be able to set up the low power. I can't find a scrap chassis with one of these, because not all Cybernet 134s have insulated ones. But we do have a kit of insulating washers, and I'm sure I can find something that's going to fit. So we'll get this screwed back on. So this job's going to have taken longer to do these cosmetic things. Never over tighten, just need to be snug. So as far as the case goes, the front, it's pretty immaculate. Make sure these are all at minimum so we get the pointers in the right place. Turn that back up. So I'll just do that final adjustment. To low power. Right, put the power supply back on. Plug the extension speaker in this time. Oh, we're still back to this, aren't we? We're still back to this. That's nice and smooth. It was volume and RF gain which were virtually frozen. Right, let's put the main meter on the inset picture. Check we're transmitting. Normal power. 4.0 something now it's cold. We had it down as 3.95, but it's doing 4. Right, low power. Press transmit. Oops, needs to be in low power. There we are, 400 milliwatts. End of that problem. Right, we're done. I'll go and get a fibre insulator kit, see if we can find something that fits. So we've got the inner one, which would be probably more difficult to find. Check that goes, yes, that goes in. So that fills it. That's a bushing. Then it wants an insulator on the outer one. That's been on an angle because of it's probably purposely like that so that it doesn't move. So we've got this from Aldi, and it's useful for organs as well as electronics. So let's hope with something like now that's kind of thing, but it could do with being a bigger hole in the middle. That's got a little bit of free play, but I think we're all right with it. Now here's the proof of the pudding, isn't it? Does the extension speaker short out? And the answer is no. Does the one to our test instrument short out? Because that would be affected much more readily because it's a metal case. Perfect. So that's fixed that problem. Right, we'll find the lids. You don't get the bigger speaker though on these sets. Not like the Fidelity 2000 and the Harvard 420M and the Banatone 5-star. That way on. I'll just put the first couple of screws in. A bit of a miscellaneous selection. So it could do with a bit of a respray for anybody who's bothered. At the end of the day, it's a 40-year-old radio, isn't it? And the important thing is it works spot on, and it works exceptionally well. I mean, I've seen these which do 0.75 of a microvolt. So the fact this does 0.25 of a microvolt, whatever it was, fantastic. And that one which did 0.7, it isn't faulty, it's still within spec, but this would knock spots off it. I've got, I think there's 2 new ones left. Put his last original one in, so 2 missing. So the radio isn't going to rattle anymore. There we go. And knobs that actually turn and don't go skew with when you turn them. Right, I'll plug it into the test, out of the test thing and into the aerial. Switch the test gear off. Switch the soldering iron off. I might do that Harvard handheld tomorrow. Another thing is, have any of you seen one of these before? It's a electronic floppy disk for the disc cameras. So instead of using the floppy disk, it takes a memory stick. Things we use those disc cameras for nearly everything. Right. Channel 19, RF gain to full, mic gain up, la-di-da-di-da, that works, keep that there, delta tune there, 1 and a Roger, no chance. You know, it's so quiet, I know I'm in the middle of nowhere, but you'd think it was as deaf as a post. And this has knocked the spots off nearly all current models. And I'm talking about as a Cybernet 134, not just as a Rotel 240. Well, there we go. So, I hope you enjoyed seeing a Rotel RVC240. I've got one of my own, just before we wrap this up, I need a front panel for. You see that? It's broken there. And look again, the knobs are skew with where they've chucked it in a skip. What's inside it? Yeah, it's not that bad. But the front's knackered. One day we'll acquire a set which has been screwdrivered to death, and then that one can live again. Thanks for watching Rotel RVC240 Cybernet 134 set from 1981.